Hey Jack, I'm going to give you some feedback on your responses to these two questions. So the first question is a good example of a two-sample t-test. It was about the standard care versus the new treatment. And so let's take a look at your solution. So your solution, you scored a 24 out of 32. And so that's really good. You did a lot of things correct, right? You have a really nice mechanics here. But let's talk about the things we didn't understand. So anytime you perform a test of significance, you have to name the test. So either with formula or name, we would say this is a two-sample t-test for the difference of means. So we got Doc 2 for that. And so you missed your other points here at the bottom. In your conclusion, you say because the p-value is 11%, we can accept the null. And so that is false. There's two outcomes whenever we perform a test. We can either reject the null with the low enough p-value, or we would fail to reject the null if the p-value is large. Okay, so a large p-value does not have evidence to show that the null is true. So to say we accept the null is incorrect. Let's see, it says it is possible to have a type 2 error, which is correct, but you need to go ahead and put that in context. So what I like to do is go back to the question. So in context, if we commit a type 2 error, that would indicate there is a difference between these two treatments, but our statistic fails to show us that there is a difference. Okay, and then finally it looks like if you said the population was 24, my p-value would be 21%. So you got dinged here because there's no way to know what the p-value would be. It says we're going to replicate the experiment, which means we'll get totally different numbers. What they're looking for here is if the sample size decreases, then we would expect the p-value to increase because your sampling variability is going to get wider. So your p-value would increase. All right, so let's take a look at the second question. The second question was a two-sample z-test for the difference of proportions. You have the German researchers. Group A consisted with sugar. Group B had no sugar or little sugar. So if we look at your solutions, it looks like this. You scored an 18 out of 28. And so the parameter, you got to be careful here. Anytime we have proportions, they want to see P1 and P2. Or you can use any subscript you like, but as long as you use the P here, so that would be the proportion of men who had a heart attack and had a lot of sugar. P2 would be the proportion of men who had a heart attack and had little sugar. So let's be more specific on what that represents. And to use a mu was incorrect here because a mu represents an average where a p represents a proportion. And then on your normal condition with proportions, it looks like you were trying to use the central limit theorem, but that only applies with the means. With proportions, you need to reference NP is greater than 10, which in this case is 500 and some, and n times 1 minus p is also greater than 10. All right. And finally, it looks like you said a statistical advantage is that there would allow more precision. So we're going to need to be a little more specific than that, Jack. So the researchers would like to increase the significance level. If you increase the significance level, you're increasing the chances of a type 1 error. So that is a disadvantage. But if you increase the significance level, you're increasing the power, which is the likelihood of rejecting the null. So that would be an advantage. But let's walk away with a positive. You're really good at the mechanics side. You're really good at your conclusions. It's just we need to clean up our parameters, our hypotheses, and understanding the follow-up questions a little bit better.